Toxic elements are all around us. They can be found in the air we breathe, the water we drink, and the soil where we grow our food. These elements can come from natural sources like volcanic eruptions or from human activities such as mining and manufacturing. Exposure to high levels of toxic elements can cause a wide range of health problems, including cancer, birth defects, and damage to the nervous system. These effects can be devastating to individuals and communities. We need to protect ourselves and our planet from these dangers. Materials science is stepping up to provide solutions. It's a field where scientists study and manipulate the properties of materials at the atomic and molecular level. They're like tiny engineers rearranging the building blocks of matter to create amazing new materials. One of the most exciting areas of materials science is finding ways to transform toxic elements into useful and safe materials. This field is revolutionizing how we deal with these dangerous substances. Let's delve into the fascinating world of materials science and discover how it's making our world a safer and healthier place. Imagine being able to take something harmful and transform it into something beneficial at the molecular level. That's what materials scientists are doing with advanced molecular engineering. It's like rearranging the letters in a word to create a whole new meaning. One way they achieve this is by using special materials called nanomaterials. These materials are incredibly small, even smaller than the width of a human hair. Because of their tiny size, they have unique properties that allow them to interact with toxic elements in extraordinary ways. For instance, scientists have developed nanomaterials that can act like tiny sponges, soaking up heavy metals like mercury and lead from contaminated water. Once trapped, these toxins can be safely removed and disposed of. In another breakthrough, researchers have created nanomaterials that can break down harmful organic pollutants into harmless substances. This technology has the potential to clean up contaminated soil and groundwater, making our environment cleaner and safer. Materials science isn't just about transforming existing toxic elements, it's also about creating new, safer alternatives. This is where the development of synthetic elements comes in. Scientists can now create entirely new elements in laboratories, carefully designing them to have specific properties. One of the key advantages of synthetic elements is that they can be engineered to be less toxic than their naturally occurring counterparts. For example, researchers are developing synthetic versions of rare earth elements which are crucial for electronics and green technologies but are often mined using environmentally damaging methods. These synthetic alternatives can be produced in a more sustainable way, reducing the environmental impact of these important materials. Furthermore, scientists can tweak the properties of synthetic elements to make them more efficient for specific applications. This means we could have more powerful batteries, more efficient solar cells, and faster electronics, all while reducing our reliance on toxic elements. The possibilities are truly groundbreaking. The true magic of material science lies in its ability to turn problems into solutions. Toxic waste, once a major environmental hazard, is now being viewed as a valuable resource thanks to the innovative applications of materials science. Industrial processes often generate toxic byproducts that can pollute the environment. Materials scientists are developing ways to capture these byproducts and transform them into useful materials. For instance, fly ash, a byproduct of coal combustion, can be converted into high-performance concrete. Catalysts are substances that speed up chemical reactions without being consumed themselves. Materials scientists are developing catalysts made from toxic elements that can be used to create environmentally friendly fuels and chemicals. This reduces our dependence on fossil fuels and paves the way for a more sustainable future. Medical isotopes are radioactive elements used in medical imaging and cancer treatment. Materials science, when integrated with LFTR technology, is revolutionizing the production of medical isotopes by leveraging thorium fuel cycles. LFTRs minimize long-lived radioactive waste while generating valuable isotopes like molybdenum-99 and iodine-131 as byproducts. These isotopes, essential for medical imaging and cancer treatments, are produced more efficiently and sustainably compared to traditional reactors. By tapping into alternative sources through thorium reactors, we can significantly reduce reliance on legacy nuclear reactors, decreasing environmental impact and enhancing the availability of critical medical resources. Learn more at adaptiveenergysystems.com.